So, Charlie Soulis and gosh, shout out to Testur Energy. How does one communicate the potential of an induction motor, powered by two Tesla turbines, which by definition must operate within the diameter of these, unless of course these bolts form no part of the drive mechanism. See, I'm thinking of making this into the drive mechanism component, reprinting it perhaps, or maybe not even reprinting it, just printing a length by whatever section, free running, to which, but then you see you've only got a limited shaft length. Limited shaft length. Now, for want of explanation, is this a stepper motor or is this an induction motor? Well, I'll spin it and then you'll have the answer. There you go, there's no cooking. That's an induction motor. Right. So the diameter of the Tesla turbine does not have to be restricted by these bolts. I'm now removing these from the assembly. And I'm going to make some assumptions from the nameplate and the size of the fuse in the device, which has got a 13 amp fuse with a 5 amp fuse mounted, a 13 amp socket, no, a 13 amp plug with a 5 amp fuse. Now, I suppose we could say we could pass, or yeah, one way of looking at this is to say, if I'm going to work this machine aggressively, I could try to get it to produce to draw 13 amps. Probably, if that happens, this circuit isn't fit for purpose, and the 7 microfarad capacitor is not going to be in sync with this capacitor in here. I'm trying to drive this at 1550 RPM, and I expect to produce, if it is a 1 kilowatt motor, 800 watts. The general mode of operation is that it will be spun up using alternating current and then driven to a harmonic between load and the structure of the motor, which I have no intention of dismantling in order to glue magnets into. Right? I mean, if I can't... It is possible to put a permanent magnet rotor inside this housing, but I would much rather not split it apart and spend all that time gluing when capacitors and the circuitry up here could do the same job. I think that's about the summary of it. It took 6 minutes to get there. Murray Smith says it in one sentence, which is, if this normally runs under no load, sorry, it's the maximum load that this will ever run under the maximum power consumption of this motor cannot be exceeded in practical terms by the amount of power it can produce if that shaft can be held at constant velocity. And moreover, it will find its own velocity and cog because of the structure of the windings inside of it. I think that's what he said. Now, somebody said I laugh at him. Well, I wouldn't want to laugh at him because, I mean, he's an inspiration. But at the same time, the video that was produced about this stuff was sorely lacking in detail as to how this circuit might work. Or not specifically this circuit, because this is a driving circuit. There'd be no harm, I do believe, in bumping the capacity of these. And then a certain amount of alternating current would be introduced. Then the machine would be brought up to or the machine would be made to speed up further, and contingent on the load, the supply of compressed air to a Tesla turbine on either side might be mediated, controlled. But I think it's true to say that the device will find a mechanical harmony at which it will lock. It will lock with the load being demanded of it. So what that effectively means is that before the 240 volts goes off, you start it. Once it is up to speed, you accelerate it a modest amount. You then allow it to, you then monitor the flow of current, the directional flow of current, the amount of current, the total quantity of current flowing in the AC supply. You'd monitor the current and the voltage of the AC supply, and you would observe the current flow to reverse direction. Now, you would observe the current flow to change sign. The Hall effect sensor would change from being consumption of power to export of power. So, this device needs to be equipped with a current sensor, a directional current sensor, and a voltmeter. We will observe some increase in we will observe some increase in Alright, I have to say that what happened there was, whilst I was trying to explain to myself what I need to measure to determine whether or not this device is going to generate power when driven, these windings in here, look how beautifully that turns. This is a twin edge shower thing. Pressure increaser, but that's taken all the pump off. These are temperature sensors which introduce an element of logic through this board, and I want to eliminate that logic. I want to know that this has a direct relationship between this shaft speed, rate of rotation, and the power supply lines to this, and the power supply lines coming in on this. So, as I understand it, the export of power is going to take place as you unplug it. So there is a serious point, which would mean if you pulled this out and this was still spinning, pulled this out and this was still spinning, that movement of putting your thumb across the live and neutral would be catastrophic, whilst this was still spinning. As soon as this stops spinning, so long as these are discharged, the device is safe. Now, in a way, these cannot overcharge because its alternating current, and the termination of the cycles will result in the cycle stopping somewhere under load, even if it is only the frictional load of the bearings. The magnetism induced in the rotor will be dissipated, and it's quite possible that this is actually not working or spinning because there is some residual magnetism. I find that slightly difficult to believe. Some residual magnetism in the rotor. Well, it's no good using those to test for magnetism, is it? But I think this is a logic board, and because I wish to make this utterly simple and clearly transparent what is going on, I need to come to the point of saying that there is a black wire, a brown wire, and a blue wire going down to the motor. Now, do I want to take out... I don't think I want to try and take out the wiring. I'm happy with this at 800 watts. What ringing or what harmonics do I wish to control as these wires and the wires that are inside here find their... Should, for example, I introduce some diodes when I also put in some capacitance into the circuit? Probably not, because I'm driving the external field, which doesn't rotate, pretty directly, simply using a capacitor, two capacitors, or even one capacitor. I believe it's possible to do it with just one capacitor. This is not a C2C three-phase circuit. Now, let's just think about this. With a stepper motor, I can pulse the electricity into this motor to my heart's content with a stepper motor controller. So if I was to say pulse it in at a rate of 50 hertz sinusoidal AC, I would then have control of the motor. I could increase the volts and amps and observe not the instantaneous current consumption or export, but merely vary volts and amps impulses, frequencies, and I'd have all that under my control, including, what do they call it? Micro stepping. So I could basically say pulse for so much time and then drop to zero with a straight line. So that would control input to the machine. And then at some point the machine would move ahead and generate more amps than was being supplied to it. More amps. Not sure, I haven't really lost the plot here, because I got this fantasy that I would use a stepper motor control on an induction motor, and that seems a bit crazy for the simple reason that (23:11). That's a lot more circuitry to involve. What would be best is if I had a capacitor plus a variable resistance to ground. Then I could control the yeah, well, that's fair enough. Oh, it's time to make some tea.